You cannot use number 4 conductors to feed each subpanel instead of number 2's. According to table 310.15b6, the ampacity of conductors feeding a subpanel must be at least 100% of the rated current of the overcurrent device protecting the subpanel. In this example, the subpanels are each rated for 100 amps, so the conductors feeding them must be sized for at least 100 amps. Number 4 conductors are only rated for 70 amps, so they cannot be used to feed 100 amp subpanels. Number 2 conductors are rated for 90 amps, which is insufficient, so they would not be the minimum conductor size used to feed the subpanels. To clarify further, let's delve deeper into the National Electrical Code or NEC requirements for subpanel feeder conductor sizing. The NEC specifies that the ampacity of the conductor supplying a subpanel must be equal to or greater than the rating of the overcurrent protection device protecting the subpanel. The overcurrent protection device is typically a circuit breaker or fuses. This ensures that the conductors can safely handle the maximum current that the subpanel is likely to draw. Table 310.15b6 provides specific guidance for conductor sizing in dwelling units. It allows for some reduced conductor sizes for service entrance conductors and main feeder conductors under certain conditions. However, this table is often misinterpreted to apply to all subpanel feeders, which is incorrect. It's crucial to understand the specific conditions and limitations outlined in the table. The table specifically applies to dwelling units and has restrictions on the total load and demand factors considered. In the given scenario, where you have a single-phase dwelling with a 200 amp service and you want to add a 100 amp subpanel in the basement and then another 100 amp subpanel in the garage, table 310.15b6 does not permit you to use number 4 conductors for the 100 amp subpanels. This is because the table does not generally apply to subpanel feeders, and even if it did, the conditions might not be met to allow for the reduced conductor size. The general rule is that the conductors must be rated for at least the overcurrent protection device. Number 4 conductors typically have an ampacity of 70 amps, which is insufficient for a 100 amps overcurrent device. Number 2 conductors with an ampacity of 90 amps also do not meet the minimum requirement. To correctly size the conductors, you need to refer to table 310.16, which provides the ampacities of insulated conductors rated up to 2000 volts. This table lists the allowable ampacities for various conductor sizes based on their insulation type and the ambient temperature. For a 100 amp subpanel, you would need to select conductors that have an ampacity of at least 100 amps according to table 310.16. Depending on the conductor's insulation type, you might need to use number 1 or even larger conductors to achieve this ampacity. It's important to note that the ampacity of a conductor can also be affected by factors such as the ambient temperature, the number of conductors in a raceway or cable, and the type of terminations used. Correction and adjustment factors must be applied as necessary to account for these factors. For example, if the ambient temperature is higher than 30 degrees Celsius or 86 degrees Fahrenheit, you need to apply a correction factor to reduce the conductor's ampacity. If there are more than 3 current carrying conductors in a raceway or cable, you need to apply an adjustment factor, which also reduces the conductor's ampacity. These correction and adjustment factors are outlined in table 310.15 cone and 310.15c2 of the NEC. In addition to the ampacity requirements, you also need to consider the voltage drop in the conductors. Voltage drop occurs when the voltage at the load end of the conductor is less than the voltage at the source end. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends that the voltage drop on feeder conductors should not exceed 3% and the total voltage drop on both feeder and branch circuit conductors should not exceed 5%. To minimize voltage drop, you can use larger conductors or shorten the length of the run. There are voltage drop calculators available online that can help you determine the appropriate conductor size for a given load and distance. Furthermore, the NEC specifies requirements for the type of conductors that can be used in different locations. For example, conductors installed in wet locations must be listed for use in wet locations. Conductors installed underground must be identified for direct burial. It's essential to select the appropriate type of conductor for the specific application to ensure safety and prevent premature failure. The NEC also provides requirements for the installation of conductors. Conductors must be properly supported and protected from physical damage. They must be installed in accordance with the manufacturer's instructions and any applicable local codes. It's crucial to follow these installation requirements to prevent electrical hazards and ensure the longevity of the wiring system. Therefore, to reiterate, Table 310.15b6 is not applicable in this situation, and you need to size your conductors based on Table 310.16, taking into account any applicable correction and adjustment factors, as well as voltage drop considerations. Selecting the appropriate conductor size and type is crucial for ensuring the safety and reliability of the electrical system. Consulting with a qualified electrician is always recommended to ensure that the installation complies with all applicable codes and standards. Consider the following key takeaways. Firstly, Table 310.15b6 has limited applications and does not generally apply to subpanel feeders. Secondly, conductor ampacity must be at least 100% of the overcurrent device rating protecting the subpanel. Thirdly, factors like ambient temperature, number of conductors in a raceway, and voltage drop must be considered when sizing conductors. Fourthly, select the appropriate type of conductor for the specific application and location. Fifthly, install conductors in accordance with the NEC and manufacturer's instructions. Correct conductor sizing is fundamental to a safe electrical installation.